Okay, let's do one problem with signs in the argument. So we have sine, parenthesis, arc cosine of negative 2/3. So we want to know how much is this expression. So we have to evaluate this expression. It's okay. So the beginning is always the same. You take your right triangle. Remember, it's a very graphical way to do this. And, well, we need to find the sine of something. So sine of theta. So this is my answer, sine of theta. Okay, now, because I want to match these two expressions, sine with sine, so the theta is the arc cosine. So theta equals the arc cosine of negative 2/3, correct? Okay, now, this is the cosine, the inverse of the cosine, arc cosine. So what I'm going to do is simply flip this one, and then I'm going to take cosine of the angle, cosine of theta is negative 2/3. Negative 2/3, correct? Now, here is the point. A negative at the front means that you can have negative 2 over positive 3 or positive 2 over negative 3, correct? But what is the definition of the cosine? Well, the definition of the cosine is adjacent over hypotenuse, correct? So we are going to match these two numbers with these two expressions. So adjacent has to be the 2 and hypotenuse has to be the 3. But here the situation is the hypotenuse is always positive. So this expression cannot be possible, correct? So I found that the adjacent is negative 2 and the hypotenuse is 3. So I'm going to put here 3. And then this is the adjacent. So this triangle is really in this direction. So this is 2. This is negative 2. So it's going to be something like this, correct? So this triangle is not really the one I'm going to solve, but this one. So this is the angle theta, correct? This is the right triangle. And, well, the only thing I have to find is the missing side. So this is 3 also. So c squared equals a squared plus b squared. So I have 3 squared equals negative 2 squared plus b squared. Solving this, which is 9 equals 4 plus b squared. So b is the square root of 5. But the situation here is, okay, if I'm letting this go in any direction, this could be positive 5, positive square root of 5, or negative square root of 5. So I can have both. So this could be also in this direction. So could be negative 2. This is negative 2 right here. And this could be positive square root of 5, negative square root of 5, correct? So, well, I have to answer. So, well, I have to live with that. So the sine of the angle for this case is going to be opposite over hypotenuse. Then, okay, the opposite could be positive or negative 5. So I have positive, negative square root of 5 over the hypotenuse. Well, that's always 3. So that's my answer. So my problem's answer is going to be sine of arc cosine of negative 2/3 equals positive or negative square root of 5/3. So I have two answers. I need additional information to determine which one of these is going to be. So where is the point? If it's in the third quadrant or is in the second quadrant. So as much as I have here, I don't have this information. So I'm going to live with these two answers now, correct? So this is the way. So in this case, we have two possible answers. We need extra information to determine exactly which one. Okay, Braulio? You get pretty much something like this? No? No, no. Okay. No more questions? No, Kevin? One of with variables, all of the variables are fine? Let me just show, let me see. Screen, this one. For instance, in pages 3 and 4. Or these, all these ones are fine? Or there is one of these that is bugging you? 10, 11, number 10. Okay. Let's work problem number 10 then. Yeah. So for problem number 10, I have the secant of the arc sine of x minus 1. I want to find what is this expression equals to. So let's just take this. Now this is my expression. Secant of r sine of x minus 1 equals what? Okay. Even if you don't believe it, these problems are simpler than the ones with numbers, because we are not going to have here the problem of the positive or negative. We are always take negative. So always we're going to have a right triangle, right? Like this. We're not going to be figure out if this is in the third, fourth quadrant, or I don't know. So I need to determine the secant of the angle, where the angle is going to be the arc sine of x minus 1. If I use the inverse function, I find that sine theta is x minus 1. Now I'm going to do this. I'm going to make this as a ratio, x minus 1 over 1. I'm going to transform this in a ratio. Remember, any number over 1 is a fraction. Now, what is the definition of sine? Opposite, hypotenuse. So the opposite is going to be the top number, the hypotenuse is going to be the bottom number. So the opposite, I'm going to put it here, is x minus 1, and the hypotenuse is 1. Correct? Then I'm going to determine this side. Okay, what is this side? Okay, no problem. C squared equals a squared plus b squared, middle school math. Then the c is 1, a squared, and b is x minus 1 squared. So I have to plug in these numbers in the Pythagorean theorem. Then I square, and this is 1, and this is x minus 1. So a squared is 1 minus x minus 1 squared. I don't have to expand this thing, okay? You can leave it like that. Okay, once you have this, you square root, so a equals the square root 1 minus x minus 1 squared. Now, we're going to take, in this case, always the positive root, right? Because technically we have positive and negative, but we're going to use always the positive. Then, this portion right here is the square root of 1 minus x minus 1 squared. So that's the value of this adjacent leg. Okay, now, once I have this one, I need the secant of the angle. Okay, the secant is defined as hypotenuse over adjacent. That's the definition of the secant. Well, I just watch my triangle. The hypotenuse is 1. The adjacent is this new expression I got. So I have 1 minus x minus 1 squared. Correct? And I'm not going to worry about this root. I'm going to leave it like that. So I have to write my final answer with this expression I get at the beginning. X minus 1 equals 1 over a square root of 1 minus x minus 1 squared. So this is going to be my final answer. Okay?
Okay.
It's going to be. So you see, it's the same expression, it's the same procedure, nothing really new. So this expression is a trigonometric ratio. This is the angle. So I have secant of theta. I draw a triangle. Then the theta is this expression, so I just use the inverse. If this is sine, I put sine here, and then I remove this one from this side. I get this expression, make a ratio. You don't have a ratio. Use the definition of the sine, and then you match opposite with the top and bottom with this one. Then you write them in the triangle, use the Pythagorean theorem to find the missing side. And once you have the three sides, you get, okay, I need the secant. The definition of secant of this ratio is this, a hypotenuse adjacent. I read the sides from my triangle, I write them, I finish. So it's not that really difficult. It's pretty fine. Okay? A ver, Kevin, you think you can do the other ones, or from the other ones you think you have trouble? Or you are fine? Bethany?
Number 7.
Number 7. Let me see number 7. Oh, this 7. Okay. Let me just show the 7. This one?
Yeah.
Sine of arc of x minus 2 over 2. Okay. Let me just copy the problem. You're going to see that it's very easy. Sine of arc sine of x minus h over 2. And I have to find this, the value of this ratio. Okay. Okay, here is the problem, correct? Well, the same. To make my life easy, I usually use the right triangle. And, yeah.
Yeah, but you need to shake your feet off before you go upstairs because there's a lot of hair.
So I need to find the cosine for this triangle. So I need to find cosine of theta. Correct? I need to find cosine of theta in this triangle. I'm going to match these two expressions. Okay, theta is arc sine of x minus h over 2. Correct? X minus h over 2. Okay. I use the inverse, correct? So I'm going to use sine theta equals x minus h over 2. Correct? Now I'm going to use the definition of sine. Opposite over hypotenuse. That's the definition of sine. Okay, now I match. The opposite is this value. The hypotenuse is this value. So I'm going to write it. This is 2, and this is x minus h. Correct? Now, I'm going to find this missing side. Okay. C squared equals a squared plus b squared. It's Pythagorean theorem. Okay, the C is 2. 2 squared equals a squared plus x minus h squared. That is going to be my Pythagorean theorem for this triangle. Now I need to solve for the leg, a. Okay. A equals the square root. 2 squared, that's a 4, minus this, minus x minus h squared. Okay. Now I know the expression, so this is a square root 4 minus x minus h squared. So that is my expression for this side, x minus h, correct? Okay, now I'm ready to go. I need the cosine of the angle. Well, the cosine is adjacent over hypotenuse. Okay, I read my triangle now. Adjacent is this expression, a square root of 4 minus x minus h squared. And the hypotenuse is 2. So I put a 2. My answer at the end is going to be cosine of the arc sine of x minus h over 2 is going to be 4 minus x minus h squared divided by 2. So my answer is a long expression, but was not really difficult to find it. Okay. Pretty much everybody fine. Okay. Well, do you think you can go through the next problems by your own? Yeah, Bethany? Or you have another question? It's okay, Kevin? Then? Okay, don't forget, solve the problems and take pictures, upload to your Google Drive and share, you know where, M. Ramirez 2 GP Apps Galena Park ISD.com. There is. That's it. M. Ramirez 2. M. Ramirez 2. Right?
So there's two E's.
Este es Z.
There's
M. Ramirez 2, GP Apps, Galena Park, ISD.com. Okay? Try to turn in this tomorrow. I'm going to do the grading on Sunday. Yeah? On Monday, we begin with new topic. I hope to have more people. Okay?
okay.
Well, take care, niños.
Mhm.
Safe. Work hard. Study the other classes also.